Now we will move forward with our next speaker for a day. Let me introduce you our next speaker, Mr. Atul Bhobe. He completed his bachelor from Mumbai University and MSc Civil and Urban Michigan, USA. He is a structural engineer and presently the managing director of Tpf Engineering Pvt Ltd, India, and he is on board director of Tpf Group. He is a life member of various professional societies.
Thank you.
His experience of over 33 years in a field of structural consultancy in general, bridge engineering and infrastructure. He is a well recognized and popular speaker at various forums. He published and represented over 150 papers in national and international seminar. He has won several awards for bridge and structural design over the last 3.5 decades. Please welcome on the stage Mr. Atul Bhobe with a great round of applause. I request Hitali to present with a token of love from Epicons.
Thank you. Thank you. So after a long presentation on IBMS, which incidentally stands for Indian Bridge Management System, as Sachin likes to call it, but it's more integrated bridge management system. For those of you uninitiated who don't know what IBMS is, it's integrated bridge management system. Okay, I'm going to talk about the follow-up to the talk that Sachin has given, and it's about what we experienced when we started doing work under the IBMS program of Ministry of Road Transport and Highways. There's one part of my talk, and the other part of my talk at the end, I'm also going to talk about what's actually happening in the field when we talk about structural audit, structural safety, structural stability, and bridge collapses, which everybody keeps talking about. So before we go into details of what I'm going to talk about, I'm going to tell you what the flow of the presentation is. You're going to see a list of codes for bridge asset management. What was the situation prior to inception of IBMS by the ministry? What is IBMS? What's the current situation of IBMS? What are the problems that we encountered while implementing IBMS, and what are the solutions we found? And what's the future of IBMS? That's the general flow of my presentation. But before we actually begin with the first slide of the presentation, I'm going to talk a little bit about the human life cycle and the structure's life cycle. So if you imagine the human life cycle and you imagine the steps that one would take in a human life, so the typical human life cycle starts with conceptualizing about having a baby, right? Then you conceive the idea of having a baby. You then are pregnant with the baby or are pregnant with the idea, and then you deliver the baby. That's the typical life cycle of achieving the delivery of a baby. If you compare that with the structural life cycle, what do engineers do against all these steps that you would do in a human life? The conceptualizing of the idea is the feasibility study that we carry out. Conceiving the idea is the detailed project report, the DPR, that you prepare for every project. Being pregnant with the idea, which is the longest period of this cycle, is 9 months, is the construction period, is 3 years, 4 years, 5 years, 2 years. And delivery of the baby is delivering the constructed project. Now, if you look at these two cycles, typically the human life cycle involves maybe one doctor, maybe 2 doctors, you have a gynecologist, maybe sometimes you have a pathologist, you have a radiologist. I'm talking of specialties of medicine. Compare that with the structural life cycle. You have geotechnical investigation engineer, you have the survey engineer, you have the design engineer, you have the bridge engineer, you have the road engineer. You have 20 engineering disciplines which need you to deliver this part of the cycle. this part of the cycle, even in the structure's life cycle, is only 3 to 4 years. A DPR, well, in most projects. In many projects, this itself could be 20 years. Like MTHL is going on for 30 years in this cycle. But okay, normally this cycle is maybe 2 to 3 years or 4 years. And then, once you have delivered the baby, the structure is expected to live, as per the current code of practice, for 120 years. 120 years. The average human life expectancy at this moment in India is about 70 years, 75 years. So your structure is going to far outlive the human life. How many doctors do you need in a human life of 70 years? If you imagine the doctors and the specialities of doctors that you would go to in a human life, let's say in the life cycle between 35 years to 70 years, you could list very easily, even a layman could list 20 medical specialities. Compare that with the structural life cycle. In the 70 years of the bridge, how many engineering specialities do we have that you can count on your fingers that are available to you? At this moment, none. It's the normal bridge engineer or the normal structural engineer, in the case of a building, is the RCC consultant, as they call it, shamefully, but the RCC consultant or the structural consultant or the bridge engineer who takes care of the 70 years lifespan of a bridge. We don't have enough adequately trained people to take care of our bridges and structures. This is true even for buildings. Unfortunately, we have more buildings than bridges, of course. Everybody knows that. So this is a term that you must have heard increasingly these days, demographic dividend. India is currently reaping the benefits of a demographic dividend in terms of population. Out of the 1.2 billion people we have, 120 crores, 50% or 60% of the population is under 35 years. You must have heard that n number of times everywhere. That's called the demographic dividend. Sachin already told you that we have 65% of our bridges which are, 65% of our bridges which are over the age of their life, which is 50 years, which was 50 years when they were designed, which was 70 years at one point in time, it's now 120 years, as per the current code. Which means that for the structures in this country, we are unfortunately in the wrong end of the demographic dividend. We are not reaping demographic dividends, we are actually in the zone of demographic loss, as far as structures are concerned. So with this in your mind, you must realize what's happening on the ground. All these structures that we are talking about, all the collapse, etc., all the bridges that are shut down and so on and so forth, these are being done because we don't have adequately trained bridge engineers actually inspecting the bridges. We have the same engineers who are delivering the baby and taking care of a 70-year-old person, if I can call it that, because a bridge itself is a living, breathing animal. Okay, it's as much breathing and living as a human being is. And unless we have adequately trained people to understand what's going wrong, it's very, very difficult to come to a conclusion. You know, Sachin said that human intelligence is required more than anything else to identify and come to a prognosis on what's going wrong. It reminds me of a very awful joke, what we used to call a poor joke. एक माणूस गेला डॉक्टरकडे, डॉक्टर म्हणाला या बसा, काय झालंय तुम्हाला? तो म्हणाला डॉक्टर तुम्ही आहे का मी आहे? तुम्ही सांगा मला काय झालंय ते, मी कशाला सांगू? The question is that if the bridge cannot talk, right? You need to look at a bridge and decide what's wrong with it. That's even more difficult. That's 10,000 times more difficult than diagnosing a patient. Okay? So imagine something like this. You know, a patient walks up to you and says, you know, here I am, tell me what's wrong with me. Or go back 150, 60 years, we used to have the old Nadi physicians in the olden times who used to check your pulse and tell you what's wrong with you now and what's going to go wrong with you 5 years hence, 10 years hence, 20 years hence, and you're going to live for 20 years. Unfortunately, we don't have Nadi physicians anymore in the country. They're all out of fashion. Is replaced, the homeopathic and Ayurvedic is replaced by allopathy. In the same fashion, in engineering is getting replaced by specialization, and for everything we need a specialist. Okay, and unfortunately, we don't have those specialists. So with that background, let's look at all these talk about IRC codes and we don't have enough codes, etc., etc. The first code that the IRC published was as early as 1978. So this is the Highway Bridge Maintenance Inspection Manual, which is still in practice. We still use the same manual for inspection, unfortunately. It's been published in 1978. That's the first document that's available in IRC. Then in the year 1990, 12 years after the first document was published, the next document is Guidelines for Inspection and Maintenance of Bridges. Now this guidelines is available to everybody. That's the famous SP 35. That's available for the last almost 30 years. But it's just available. Nothing has been done. It's just been published and we just leave it at that. We don't do anything after that. Then of course we have guidelines on techniques for strengthening and rehabilitation of bridges as early as 1993. And if you read this document, this actually talks about external pre-stressing in 1993. As early as 1993, you must know, the Ganga Bridge at Patna, external pre-stressing was done in the year 1990, 89, 90. That's when they started doing external pre-stressing. The Thane Creek Bridge external pre-stressing was done around the same time, 1990, 91. So the technique existed. It was not codified. We still don't, in fact, have a code for external pre-stressing. It's being written now, even as we speak. But this is available. SP 40 was published in 1993. We have a bridge inspector's reference manual, for whatever it's worth, published in 1999. In 2002, we have an approach document for assessment of balanced life of bridges. So imagine the amount of knowledge that we have created. In IRC, we have a document which talks about balanced life of bridges. Again, we only talk about it. Okay, we don't do anything. Then in 2008, we have guidelines for retrofitting of steel bridges by pre-stressing. Now this is an extremely, what should I say, extremely sophisticated method of retrofitting steel bridges. But we have a guideline for this as well. Okay, IRC has a published book talking about retrofitting of steel bridges. And then finally in 2008, we have guidelines for corrosion prevention, monitoring and remedial measures for concrete bridge structures. In 2008, we are now closing in on 2020. This is 12 years old. But this is still not a code, it's still guidelines. All those documents, none of these are codes. An SP is special publication, these are guidelines. None of these have been converted to codes. So when Sachin says that codes are not available, I put that in inverted commas, what he means is that there is not a regular IRC number for these particular documents. All this is in the form of knowledge, is in the form of a document. It's published by the Indian Roads Congress, but it's still not a code. It's of course available in public domain. It's not a secret. There have been committees after committees after committees talking about this. And what I've listed out here is the first year of publication of these documents. These documents have been over the years modified, reprinted, republished. They undergo continuous change, so much so that I think IRC SP 40 is going to be just published or has been published. The draft is in circulation, I know, but I don't know if it's been published or not, but it's just under new publication. And of course, there's the guidelines of evaluation of load category capacity of bridges as well. And then finally, we have a guideline for load testing of bridges. Okay, so these guidelines are already available. All of these are again SPs. None of these is a code. All of these are special publications, just in the form of information. Of course, you will see that none of these include specifications for NDT or categorization of bridges, prioritization of bridges, allocating budgets, etc., etc., etc. These are all in the domain of future codes that will be published or revisions of these documents that will happen over a period of time. So before what prompted the Ministry of Road Transport and Highways to get into IBMS? Quite frankly speaking, IBMS as a concept has been existing with the ministry since 1989. That was the first conference. If you look at the conferences that Indian Roads Congress and the IABAC has in India, the first conference on load rating and assessment of balanced life of bridges was done in India was 1989. As early as 1989 was in Bangalore. But again, we kept talking about it. It was not till the year 2004-2005 when an innocuous question asked on the floor of the parliament, a star question asked by one of the MPs on the floor of the parliament, which asked the minister, the honorable minister, to reply to a simple statistic. The question was, how many bridges do we have on the national highway network of India? This was, I think, 2005, 2006. And the answer to that by the honorable minister was, we don't know. That was stark reality at that time, till 2004, 2005, when ministry started the program of IBMS. 2005, I think, was when they actually decided to start. But it took 2014, 2015 for the program to actually be implemented. And a lot of things that we do, Sachin mentioned that we go in circles. I think as engineers or as Indians, and I always say this, we have a very strong belief in Newton. Why do I say that? I don't know how many of you remember Newton's first law. A body at rest will not move until acted upon by an external unbalanced force, inertia. That is the biggest problem that we have, inertia. We just don't want to change. If you want to change something, we don't have a code. You don't need a code to do work. You can execute the work. You need a code because you are afraid that something will happen, that there is a fear, like Sachin mentioned. He correctly mentioned that there is a fear that somebody will point fingers at me for doing something new, something out of the ordinary, what the world calls innovation. We are killing innovation because of Newton. Okay, so get that Newton out of your mind. We are firm believers of Newton. Everybody should place a photograph of Newton in their Devara and worship him, because we trust and believe Newton's first law like nobody else in the world. So implementation of IBMS was started in 2015. That was the first time that the ministry decided that they would do it. And 20 consultants were mandated with doing this work. One consultant was the consultant handling the data center in Delhi, creating the data center and handling, which is IBMS, which is Sachin and his team, who did a wonderful job sitting in Delhi, developing the whole system. And 19 other consultants who were field consultants who were mandated of going over about 10,000 kilometers, an average of 10,000 kilometers each all over the country. Less than 10,000 actually. The average would work out to about 5,000, because in 2015 when this work kicked off, we had a national highway network of 96,000 kilometers. Currently we have reached about 130,000 kilometers or something like that, but at that time it was 96,000 kilometers, and the data that we have generated in IBMS relates to this 96,000 kilometers plus some additional few thousand kilometers, not the full 140,000, but I think 10,000 or 12,000 more kilometers were added. So 108,000 kilometers or something like that is what the data is all about. A comprehensive global inventory of structures was missing, although some data existed within the network. What do I mean by this? Individual state PWDs, individual urban local bodies, etc., did have some data available with them because of concerns that they had noted about the bridges in their territory. For example, somebody mentioned the Thane Creek Bridge. The old Thane Creek Bridge was part of the National Highway Network. It was the Zuari Bridge in Goa, the Ganga Bridge at Patna. They were all part of the National Highway Network. The local PWDs started seeing defects, obvious defects in those bridges. They brought it to the notice of the ministry, who sanctioned money. And so some data existed within the network. We didn't have a global comprehensive inventory of bridges. Periodic condition surveys and balanced life assessment was missing. There was no specific budget for repairs and maintenance of structures due to absence of global data, and a scientific approach to the same was missing, obviously because you didn't know how many bridges you had. And so you followed a piecemeal approach to repair and maintenance of structures on an ad hoc basis and on identification of urgency, sometimes leading to catastrophic results. Some of you might know that the span of the Ganga Bridge actually deflected by almost a meter before they closed that bridge. They waited till it deflected almost 2.5 feet before they closed off that span and then let the other bridge run. And mind you, even today the bridge is in extreme distress, and it's still used by people. It's what I call Bhagwan Bharose technology. You know, we have great belief in God, so it works. So with that background in mind, IBMS implementation was kicked off. I mentioned to you that we had 19 field consultants and one global consultant who worked out of Delhi. The problem is that when you start implementing, there's no institutional framework like Sachin mentioned. And so some things went ahead, some things didn't, some things preceded, something succeeded, whereas they were supposed to be in a different stepwise implementation. So in some cases, the global consultant was in place, but the local consultants were not there. In some cases, the local consultants preceded the global consultant, and so on and so forth. And then the database that was to be created, because of all the issues that Sachin mentioned, lack of the code, lack of identification of certain parameters, it took time for establishing that database. And then to stabilize that database also took time because of compatibility issues between hardware and software that was being used. And of course, training people in the software that was created in Delhi, the central database software took a long time. It was not easy for people to correlate the software standing on the field because the software existed somewhere else. This led to erroneous database entries which took time to resolve due to a large amount of data collection in a very short time. So what's happening is, imagine that the people in Delhi, there's a team of 20, 30, 40 people sitting in Delhi, collating data that's starting to flow from 20 people in the field. And suddenly you are looking at a lot of data to actually correct, collate, and then incrementally add it to a database. Because you need to be continuously checking that the data that is coming in is verified and correct. Because once the database is up and running, you don't want wrong data to be disseminated. Specialized manpower and equipment deployment in the field, bridge inspectors, like I mentioned already, this cadre needs specialist and or specialized training. MBIUs, mobile bridge inspection units, and you will see photographs of that in later slides. Deployment took anywhere from 3 months to 12 months because of non-availability of equipment. Now this mobile bridge inspection unit is not something that's manufactured in India, it has to be imported. And there are maybe 4, maybe 5, maybe 10 suppliers all around the world. So imagine that the cheapest supplier in the world suddenly got an order for 20 MBIUs. And he's capable of manufacturing maybe 1 or 2 or 3 MBIUs in a year. And he's suddenly flooded with 20 orders, and obviously like any other vendor, he's more than happy, he's jumping with joy because he's got 20 orders. That's a bonanza for him. So he took all the orders and he could not supply the MBIUs. So there were those consultants who were first movers who did get the MBIUs on time, but there were other consultants who did not get the MBIUs on time. Data collection was delayed. And of course, bridge inspectors, because that animal simply doesn't exist. There is no such thing as bridge inspectors in India. We don't have bridge inspectors in India. We don't have a legalized term called bridge inspector. So the lowest common denominator in the office, which is a fresh engineer, is called a bridge inspector. So he simply goes to site, and because he's inspecting a bridge, he's a bridge inspector. Okay, he has no formal training. He's just walked on a bridge before in his life when he was doing his BE, and he's come out fresh out of college, and he's standing on an MBIU collecting data, and he's a bridge inspector. Now that's something that we need to correct, and we need to correct it very fast, and that's the reason I showed you the first 2 slides, just to bring this point forth, that when we are now doing inventory of structures, there are at least 100 people out there, somewhere in the marketplace, who have done this job already. So although they are not expert bridge engineers, they are bridge inspectors, they are still better than another fresh engineer coming out of college, because they've already spent maybe 2 years, maybe 3 years, maybe 1 year inspecting some bridges. So they're at least better than most of the others. So if we want to inspect more bridges now, there is at least some level of expertise available on the ground in terms of these 100 engineers who have done something called bridge inspection. The interface between the field and the central office database was sparse due to distance, and this created many issues of coordination in data. The result was that data was collected but was incoherent a lot of times. Now this is something that will be an issue in a lot of places. Not only is the data incoherent, but what we want, the bridge identification number that you create has something called a lat long identifier, a latitude longitude identifier, which needs a GPS, which needs a mobile network for you to identify, because most of the data that was collected was done via a tab, a simple mobile phone. Unfortunately, there are areas in India which are still not covered by mobile networks. So what do you do? How do you get a lat long of that bridge where there is no mobile network? I'm sure in Maharashtra, in Gadchiroli, in remote areas where there is no network, this is going to be a huge problem. And we've also faced this problem on the National Highway network, although a little less as compared to state highways and other areas, because in state highways, you will have much more inaccessible areas to mobile networks than the national highways. National highways, fortunately, I think 90% of the national highways are covered by mobile networks, so it's slightly easier. But when we go down to the level of state highways, MDRs, ODRs, VRs, PMGSY roads, this is going to be a huge problem because networks are not available. And why was this done? It was done to overcome a very simple human tendency of filling in data sitting at home. We wanted to avoid people who sit at home, take pictures from their mobile phones and upload data by sitting in Mumbai or Delhi or Kolkata or wherever. So it was mandated that the data must be uploaded from the lat long that you are uploading. So you must be physically on the bridge at that lat long when you upload that data. And the date and time must appear also on the date stamp, and the time stamp must also appear on that. This is easier said than done. Like I said, you don't have mobile networks. And so whoever came up with this ingenious idea, maybe Sachin, maybe the team in the ministry, was flummoxed as to how to solve this problem. But okay, finally we resolved the issue. We agreed that there are some bridges which will be out of the network and which will have to be accepted as having been uploaded from areas where there is a mobile network. So we found solutions to it. But to come to this solution is not easy, because there is no, like Sachin mentioned, I like the word, institutional framework. I call it political will and bureaucratic will. There was no political will and there was no bureaucratic will to solve that problem. The best thing is to rehne do, chalne do, jaise chal raha hai. And so you end up with a situation of that last 5% or 10% of data, which is going to create a problem. But anyway, fortunately, IBMS, we found a solution which was acceptable to everybody, and then the data was uploaded. But till that time, people spent 6 months, 8 months, 10 months trying to come to that solution. So with all those problems and with all those issues that we faced, what's the current situation of IBMS? An inventory of more than 172,000 structures has been completed on national highways, which were identified in 14-15. So I mentioned to you 96,000 kilometers, give or take 10,000. So about 108,000 kilometers of national highways were inspected in the country for the first time, and there was an inventory created for 172,000 structures. So we now know that the national highway has around, I mean, I've rounded off the number, there it could be 170,545 or something like that. But we know that we have that many structures, and each of these structures has a bin, so you know exactly at what lat long you have which structure. And then, of course, all the details of that structure also appear if you enter them. This is what it covers: 134,000 culverts, 32,000 minor bridges, 3,600 major bridges, and 1,800 extra long bridges. Now, the way that this was defined was anything more than 600 meters is an extra long bridge. Anything between a minor bridge and 600 meters is a major bridge, and of course minor bridge is a minor bridge and a culvert is a culvert. So you have data of 172,000 bridges that exist. Now what scares me, and when I talked about the demographic dividend earlier, imagine that for 108,000 kilometers, we have around 172,000 structures. I roughly calculated the length of these structures taking an average. We have about 5,000 kilometers of bridges on a national highway network of 108,000 kilometers. Now we are going to add another 10,000 kilometers of bridges in the country with respect to the number of metros that we are doing, with respect to urban bridges that we are building, with respect to the national highway network that we are expanding, the PMGSY network that we are expanding, and so on and so forth. Elevated roads that we are adding, the bypasses which are on elevated road, and so on and so forth. Now that's a scary thought, because out of these 172,000, like Sachin mentioned, 65% are already redundant. So instead of looking at our old parents and grandparents, we are more worried about delivering more babies. Now that's what is a scary thought, okay? But I put that thought and I leave it at that because there's not much that we can do at this forum on that particular thought, but it's something that you need to think about. 3 or 4 cycles of condition surveys are completed. When I say cycles, what does it mean? There are 2 cycles mandated for inspection every year. One is pre-monsoon and one is post-monsoon. So in the 2 years or 3 years somewhere, some contracts, 3 to 4 cycles of condition surveys have been completed. Of course, one cycle, the first cycle is inventory, so it took 1 year for inventorization and then 2 years of condition survey. So about 3 years of data is now collected. So big data collection is in progress and large strides have been made in collecting this data. It has been an extremely difficult task to come to this point. And this is where I don't agree with Sachin that we are now going in circles. No, we are not going in circles. This will move forward. The ministry has spent 210 crores already as per their own admission on this particular IBMS. So it's not something that can be thrown away. Fortunately, the amount is quite large enough not to ignore. So hopefully something will be done. We are going to move to the next step. And I'll show you in the further slides what we're going to do. At this moment, IBMS is a depository of this data, and there is a need to develop an MIS and a decision-making software based on this database. Because right now, this is just a database. It doesn't have a conclusion model or a module to this database. So we just have data available. In today's circumstance, the younger generation will know. In the older days, we used to say knowledge is power. Unfortunately, today knowledge is not power, data is power. So we have a lot of data available. Okay, so if you probably sell this to Google, they'll happily buy it because Google is the one company in the world who makes money out of data. They know how to use data, but we also know how to do it. So we are going to start using this data in an intelligent way. What are the problems encountered and what are the solutions to it? Now to me, this is the most crucial slide because we take a lot of decisions based on what we have done in bridge inventory, what we've done in the condition surveys and so on and so forth. But we do these condition surveys and inventories with a lot of ignorance. What do I mean by ignorance? So I'll tell you what I mean by ignorance. Underwater inspections have not been carried out and will need highly skilled bridge inspectors with scuba diving skills. Now this is, first, imagine that we don't have bridge inspectors, we don't have scuba diving skills, so putting them together and finding somebody is impossible, okay? These skills are available only with the Navy at this moment, and the Navy has a very extremely skilled unit of engineers having scuba diving knowledge. Of course, they are in the range of commandos, so you can't employ them for inspecting bridge foundations. But they do have this, and the Navy does inspect foundations in the bordering, bridges that are on the borders. They keep inspecting those because they are afraid of security risks. If somebody puts a bomb on the foundation, the bridge will collapse and so on and so forth. So they do have the skills, but of course they cannot be used for civilian reasons. Now this is simply not done. To my mind, the most critical area of the foundation in a river bridge which undergoes the biggest problems of scour, it's the foundation. And we have simply ignored that. We have said we don't want to do underwater inspection because of course we don't have the skills to do that. So this is something that must be kept in mind. We have this and we have not done it. So of course, foundations have not been inspected, irrespective of whether they are piles, open foundations or well foundations. And obviously we can't dig up foundations to inspect them. So foundations have simply not been inspected. Even for bridges which show deflections at the road top level, foundations still have not been inspected. There's no way that you can inspect foundations. So this has been ignored. And this is the item which is surprising to me. The deck slab top has not been inspected. Now you can't inspect the deck slab top because there's a wearing course. And nobody allows us to stop traffic because you just want to inspect a deck slab. They say, is it going to collapse? No, then don't inspect it. That's the normal answer. Because why does this come about? Because the person in charge of closing down a bridge is unfortunately not the PWD's division or the National Highway division, but it's the police. The police and the district administration is in charge of shutting a bridge down, even for inspection. And it's extremely difficult to convince somebody that I just want to check it. You know, there's nothing wrong with your bridge, but I want to check it. If there's nothing wrong, why do you want to check it? Is the question. And it's very, very difficult to convince the district administration, because in most of these locations, the bridge is obviously the only link connecting the two shores. So if you probably shut down that bridge for inspection, and imagine I open, imagine that I open out the wearing course. You have to shut the traffic down on a 2-lane bridge. You can't inspect the deck slab. Special structures like cable stay bridges, extra dose bridges, steel trusses need a special MBIU. The conventional MBIU doesn't work because it's got to go between the pylons, it's got to go between hangars. It's very, very difficult, and it requires highly skilled bridge inspectors. Now that's an oxymoron. We don't have bridge inspectors, so of course we don't have highly skilled bridge inspectors, but that's what you need. Wide deck bridges cannot be inspected since the reach of the MBIU is limited. You'll see this in further pictures. 2-lane bridges, inspection is difficult since traffic diversions are not easy, and this is especially critical on state highway bridges and on local bridges controlled by local administrations, the Zilla Panchayats, etc., etc. It's very, very difficult to shut down these bridges. Bridge ratings and balanced service life estimates have not been carried out. Now, to my mind, this is the most critical item, and that's simply not been done in the IBMS. So that's a view of the MBIU, and this is what they call the platform type MBIU. That's the platform. There you can have engineers, labor standing on that, repairing it or inspecting it or whatever. This is one type of MBIU that we have. This is the other one where we have a platform and we have a vertical platform to it. So you have a twin system where you can also inspect the sides in addition to the bottom. Then we have the bucket type of MBIU, which works off the top. And then this is the Indian MBIU, the only one that's manufactured in India. Again, a platform type, but it's at least manufactured in India. And that's how you inspect the bridges, and that's what I meant where we have a problem in the reach. Imagine this bridge has been constructed, let's say 2 meters apart or 2.5 meters apart. If this were constructed 600 millimeters away, it would have been extremely difficult to inspect this side of the bridge. So it's a limitation that we have on the current MBIUs. That's the horizontal reach of the MBIU. And that's what I mean. When you're inspecting the bridge, you simply need to shut off half the bridge or the entire bridge. You need to clean the sides. That's part of the IBMS consultant's duty, is to also clean up the sides, rake up the joints, they clean the expansion joints, clean the pier caps, and so on. So that was done as part of the routine maintenance. There you go again, that's the bridge completely shut off to traffic and only 1 lane operative at many times. And then of course you can go down right to the level of the bridge, inspect it, comfortably stand within the MBIU to inspect it. That's another inspection happening on top of water. So these are just, that's another inspection where you can go as close as you want to the bearings and inspect the bearings. Now I'll take a couple of minutes to explain to you this last slide of mine. There is a confusion between what we have done in IBMS and what a lot of people are doing on the ground, on the field. What we have done in IBMS is under the first two parts of this slide. We have done inventory and we have done a conditions survey. We have not done what I would call a structural audit, because in 90% of the cases, we don't have the designs available to us. So what we have done is a condition survey and we have left it at that. A structural audit, the normal sense of the word, you would expect that the structural engineer, when he is talking of an audit, generally at least looks at the design. This is simply not available in most cases, unfortunately, and therefore the structural audit has not been done. Continuous monitoring is the next step of what has been done already under IBMS. And then finally, we have the structural stability, which is normally confused with the structural audit. A structural stability actually needs you to proof check the design before you say that the structure is good and standing in good condition. My final slide is the future of IBMS. The query and conclusion module to manipulate big data to aid planning and management is required. Machine learning and artificial intelligence modules need to be built into the database. Modern methods of inspection need to be incorporated. The drones, for example, need to be incorporated in this. And the new structures that we are building need to be integrated directly into IBMS so as to automate data collection. And SHMS, which is structural health monitoring systems, needs to be incorporated in every new structure that we build. And we have now technology that actually doesn't need you to even physically inspect the structure unless it starts showing signs of distress on your monitor. Okay, we can link accelerometers fitted on the structure directly to a finite element model in your office. It can directly tell you what are the stress levels in your bridge continuously on an ongoing basis, minute to minute, second to second. Until it goes beyond your set benchmarks, you don't really need to look at the bridge and go and inspect the bridge, except for minor repairs like cracks on the handrails, etc., etc., etc. That's it. That's all I have to say on IBMS. Thank you very much. If there are questions, I will answer them.
Hello, sir.
Yes.
So you previously told that you didn't have that old design of the bridges. Then how did you perform the condition survey or structural audit?
No, I said we did not do the structural audit. Okay. What we have done is an inventory and condition survey. Condition survey is just the condition of the existing bridge.
So you mean to see a visual inspection?
Yes, yes, yes. Of course.
Okay.
It's a pure visual inspection.
Okay. Thank you.
Thank you, Atul. In fact, when I went to Atul, inviting him for a lecture, so he had many expressions on current scenario, but he has given a fantastic lecture. आता आम्ही मराठीमध्ये ज्याला पूर्वी डेक्कन क्वीन was the fastest train, and we used to say the Deccan Queen of the lecture. Excellent lecture. Thank you.